All right. Hey, how you doing? This is Mr. Cook, your old pal. Wait, I said that wrong, didn't I? Hey, this is your old pal, Mr. Cook. There we go. That felt better. We're going to go through the second page of the review and, go through some of these matrices here, okay? They've got some weird rules. That's why they have to create an entire class called linear algebra to describe what you do with matrices to get a particular solution. All right. So here we go. Now we're going to use Kramer's rule to solve stuff. Kramer's rule is effective in a sense. Like if you want to solve for one individual variable, it's really fast. But in general, we don't really use that for solving systems of equations. We usually just go straight for like an inverse to solve for everything all at once. But Kramer's rule is cool because you can find individual values this way. So here's how Kramer's rule works. All right. Let's say that I wanted to solve for the x value only. Well, what I would do is the following. I'd write this system of equations up as a matrix. So here's how you do it. You write up like, well, you count up how many terms that you have on the left-hand side. There's 4. So there's 2 variables, x and y. So that's going to correspond with 2 columns on your matrix. Okay, so you're going to have 2 columns. And then however many equations that you have, so you have equation 1 and equation 2, that's going to count for like the number of rows that you're going to have in your system of equations. So from here, what we do is we create something called a coefficient matrix, where we just write in the coefficient values. So like I'd plug in 2 for like one of my terms, 6 for another one. And you got to be conscious of the signs on this as well. 5 here, and then -5 for my last one. That's my last coefficient for this. All right, so next what you would do, once you put together your coefficient matrix, the next thing that you do is you put a vector, or I shouldn't say that word vector because you haven't learned that yet, a smaller matrix that's just going to represent one column, and that column has to do with the variables that you have. So it's going to be x and y, and those are going to be in the same order that you put like the your columns, your coefficients for x and y. So it needs to go like if x comes first and then y, x needs to be on top and then the y. Okay, and this will be helpful for when we have like multiple variables coming up soon, when you're writing up a coefficient matrix. And then that'll be equal to the solution matrix that we have over here, -4 and 30. Okay, so this is a column with those 2 values at the very end. All right, so now let me show you how to find or solve for x and also for y. Okay, so here we go. So remember how like this column was the x values and this column was the y values? Well, what we're going to do is take 2 determinants, all right? So if I want to solve for x, let's say, then what I do is I take the determinant of my coefficient matrix. So this thing right over here, the determinant of the coefficient matrix. So I do determinant of, that thing right there, 2 and 6 and 5 and -5, okay? And then in the numerator, so I'm just going to create a fraction because like, the determinant just gives you a number. So this is just going to turn into some number in the denominator, okay? In the numerator, I put the exact same thing. So the determinant of the same matrix, 2, 6, 5, -5. But there's one little change that I make, okay? Since I'm solving for x, I replace the x column with these numbers, like what we call the b value or the solution values. So I'm going to replace that 2 and that 5 with a -4 and a 30, okay? And then what I'm going to do is just calculate the determinants and then simplify this fraction. That's what my x value is going to end up being. So I do my little rule for the 2 by 2 determinants. So I take the corner values, -4 and -5, and I multiply them together. And then I subtract away 6 times 30. And then in the other one, I do the same thing. So the little corner values, 2 and -5. And then the other corner values, so 5 and 6. All right, let's see what we end up with here. So that's going to be +20 minus 180. So I'm going to say that is -160. And then let's see, that's going to be a -10 and a -30. So that's going to be -40. So, hey, this isn't that bad. -160 over -40 gives me the number 4, right? If I just divide it out, like, you can cancel all the zeros there, and then -16 over -4 is +4. So that means that x is equal to 4. That's how you use Kramer's rule, okay? So I just solve for x equals 4. Now I'll show you how to solve for y. It's the same procedure, okay? We're just going to use y instead. So here's how it goes. Ready? Here's how it's going to change. So we start off, the same way that we did before. We write the determinant of the matrix in the top and the bottom. But now what we're going to do is replace the y column with, the solution values over here. Okay, so we erase the y parts, and we just put in a -4 and a 30 here. Okay, so before -4 and 30 were like in this column. Now I'm like moving it to the other column because the other column is y. So we're solving for y, and this is how we do it. Okay, so let's get these values worked out. So we do the determinant. So do the corner ones, 2 times 30, and then minus, and then it's going to be a -4 times 5. And then in the bottom, that's 2 times -5, and then minus, and then it'd be 5 times 6. Let's see what we get there. So that's 60 minus, or wait, actually plus 20, which is 80. So 80 goes in the top. And then in the bottom, we've got -10 and -30. So that's going to be -40 again. Okay, so we've got 80 over -40. So the zeros at the end can cancel out. So my y value is going to be equal to -2, it looks like. So y equals -2. And once you get, these solutions, if you've got time, you've taken the test, you got all your stuff taken care of. If there's extra credit, you've already gone through the extra credit, then I don't know, why don't you just try plugging in just to verify? So I'd maybe take like this top equation here, 2x plus 6y, and I plug in the x and the y and make sure that it equals -4. Let's see what happens. So 2 times 4 plus 6 times -2. So that's going to be 8 minus 12. Yeah, and sure enough, that's -4. And it should work out for both of them. So, if you're not feeling confident still, you can still plug it in. You should get the same thing for the other equation. All right, so that's Kramer's rule. And you just, replace the variable that you're solving for. You replace that column with the solutions. All right, what else do we have to do here? So it looks like solve using Gaussian elimination with backward substitution, and then solve using Gauss-Jordan elimination. Oh, these are both pretty easy. Even with like a 3x3 case, it's not terribly difficult. Okay, so Gaussian elimination with backward substitution. So we start off by writing up our coefficient matrix. All right, so it looks like I've got 1x, 1y, and 1z. So that's 1, 1, 1 for the x column, the y column, and the z column. And then now the second equation is deceitful because this is really like saying 2x minus 1y plus 0 z's equals 12. So I'd write up the following row for my coefficient matrix. It'd be 2, -1, 0. And then the bottom row would be -2, and then -3, and then +4. All right, so here's the deal. Take your time putting together your coefficient matrix. You do not want to make a mistake with your, Gauss-Jordan or Gauss elimination algorithm. Make sure that matrix is properly accounted for. Okay, and then you guys probably learned how to make augmented matrices. So then you make your little ... there, and then we put in the solutions for all of these equations. So 4 and 12 and 0. Okay, so our goal is with Gaussian elimination, we want to create something called row echelon form. And row echelon form looks like this. Like you get like some pivot number here, okay? And then you get zeros below it. And then you go to the next row and you should get another number by itself and zeros below it. And until you basically just have like numbers across the diagonals. We call those pivots, okay? So what you can do is just like use row operations. You can use the following row operations. You can add rows together, and you can multiply rows by values called scalars to do this elimination. So here's what I would do. I would just keep this first row exactly as it is because I have a 1 right here from my first pivot. Oh boy, that is about as good as it can get. Because all I got to do is just multiply that top row, that 1, 1, 1, 4. I just multiply it by constants to get rid of this 2 here and this -2 here. All right, so here's what I'm going to do. I'm going to take that row 1, 1, 1, 4, and what I would do, I'd want to get rid of that 2 right over here. And so the only way that I'd be able to do that is by taking row number 1, multiplying it by 2, negative 2 specifically, and then adding it on row number 2. What that does is that'll get me my brand new row number 2. And that's the algorithm that I want to go through. Okay, so then I do the math behind it. Maybe I just like kind of offset it or something like that. I take row number 1 and I multiply it by negative 2. So like this top row, I get negative 2, because 1 times negative 2 is negative 2. And then 1 times negative 2 is negative 2 again. So this is how like that top row would look if I took it, the 1 and the 1 and the 4, or the 1 and the 4, and I multiplied it by negative 2. That's negative 2 times row 1. Then what I do is I'd add all of those terms to the second row. So 2, negative 1, 0, and 12. And whatever I get as a result, I'm going to replace that in row number 2. That's what this notation is saying that I'm going to do. All right, so let's see what we end up with after doing all that stuff. So here's the deal. Row 1 is going to stay the same. The only thing that I'm changing is row 2. So row 3 is going to stay the same. But what do we get when we take negative 2 of row 1 and add it on to row 2? That's what's going to replace our new row 2. All right, so let's see what we get here. 2 minus 2 is 0, so I get a 0 for my first term. Negative 2 minus 1 is a negative 3, so I get a negative 3 over here. And then negative 2 plus 0 is a negative 2, so I get a negative 2 for this one. And then negative 8 plus 12 is going to give me a positive 4. Okay, there we go. That's what I would do for my first part of getting Gaussian elimination going. Okay, the next thing I want to do is turn this negative 2 into a 0. So what I would do is I'd multiply that top row, because I've got that nice 1 right over there. That's like my favorite little part right there. And what I would do is I'd multiply this top row by 2, and then I'd add it onto this row. Okay, so I'd multiply by 2 and then add it on there. Because if I take 1 and multiply by 2, I get a 0, and that's what I want. I want a 0 in place of that negative 2. So here's what I'm going to do. Ready? I'm going to take 2 times row 1. Okay, so 2 times row 1, and I'm going to add it on to row number 3, and that's going to become the brand new row number 3. All right, so let's do our algebra off to the side. So we take 2 of row 1. So we take row 1, we multiply it by 2, so that would be 2, 2, 2, 8. And then we add that on to row number 3. So negative 2, negative 3, 4, and 0. So let's see what happens when we add those together. Because whatever that becomes, that's going to be our new row number 3. So I'm just going to retranslate all this stuff. I'm going to keep row 1 and row 2 the same. So 1, 1, 1, 4. The second row is going to be 0, negative 3, negative 2, and 4. And then my new row 3 I'm going to find by adding all this stuff together. So 2 minus 2 is 0. 2 minus 3 is going to be a negative 1. 2 plus 4 is 6. 8 plus 0 is 8. So here is our next matrix. And we are good to go with our Gaussian elimination. We keep going with it. All right. So how am I going to now work with this? Well, you can, if you want, you can swap rows. Okay. So here's what I'm going to do. I'm going to switch these 2 rows around. I'm just going to switch around row number 2 and row number 3. Just going to flat out switch them. That's it. Okay. Because what I'm going to try and do is I want my pivots, because this is like the next pivot. I want this thing to be like either a 1 or a negative 1, something that's really easy to work with. If you think that that's a little bit too complex for you, it's okay. There's a secondary way that you can do that, and that's just to, get rid of this negative 1 using this negative 3. So how would you do that with row operations? You could always take row number 2, right, and you can multiply it by 1/3. So that would give you, let's see, negative 3 times 1/3. And, that would give you a negative 1. And if you want to get rid of this negative 1 here, you'd subtract it from there. Okay, so now we're going to make that a negative and then add it on to row number 3. So this is an alternative way to think about it. you can just use whatever pivots that you have. As long as you're not afraid of fractions, it's going to be pretty easy. But if you're like intimidated with fractions, it might be more beneficial for you to swap the rows on this instead. That's kind of just up to you. It's whatever personal preference that you have. I don't mind fractions, so I'll just like kind of keep it like this because this is like the simplest approach. Not swapping rows, just keeping everything like about the same. But let's see what happens. Okay, so what I would do is I take negative a third of row number 2, so that'd be negative 3 times negative a third, and then negative 2 times negative a third, and then 4, so 4 times negative a third. And I'd add that on to the following numbers. Row number 3, negative 1 and 6 and 8. All right, so let's see what we end up with. Okay, negative a third minus 3 times negative 3 is a positive 1. Negative a third times a negative 2 is a positive 2/3. And then 4 times negative 1/3 is a negative 4/3. All right. Now, if we add these rows together, I get the following. I get a 0, and then 6 plus 2/3. Oh, gosh. Well, 6 is 18/3. So 18/3 plus 2/3 is 20/3. And then let's see, 8 in terms of thirds. That's 24/3. Yeah. So 24/3 minus 4/3 is going to be 20/3 as well. All right. So here's what we end up getting from Gaussian elimination. Ready? So this is our last one that we're going to need before we start doing backwards elimination. So we've got 1, 1, 1, 4. And then we've got 0, negative 3, negative 2, 4. And then here's our resulting last row, 0, 0, and then 20/3 and 20/3. All right, now you might hate me because of that fraction, but I happen to know a secret. And the secret is that, when I put these problems together, they all have like really nice answers, like 5 or 6 or whatever. So you'll get really nice answers for your x and your y and your z. I'll show you, okay? So now we use backward substitution. So from here, what we do is we just rewrite this as a system of equations. So remember that this is like the x's and the y's and the z's here, and that's like the solution part. So like this first equation here we get is 1x plus 1y plus 1z is equal to 4, okay? And then the second equation we get from the second row, so we have 0 x's, but we have negative 3y, and then minus 2z, and then 4. And then the last row that we have, we only have the z value. So we have 20/3 z. Ugh, that looks nasty, doesn't it? Equals 20/3. Well, wait a minute. That last one's really easy to solve, right? How do you solve for z? How do you get it all by itself? Can you just divide both sides by 20/3, right? Or multiply by the reciprocal? Either way, you get z is equal to 1, right? It's just 1. So there you go, z equals 1. That's, part of your solution, z equals 1. And if z is equal to 1, then that means that we can take this second equation and we can solve for y pretty easily. Here's how we can get it. It's negative 3y minus 2 times z. And remember, z is 1. And that's equal to 4. Okay, that's not that bad to solve. 2 times 1 is 2, so that's just a 2. And if I add 2 to both sides, that means that we get 6. And then if I divide both sides by negative 3, I get my y value. My y value is going to be equal to 6 over negative 3 is a negative 2. There you go. So there's y. And if you have y and z, solving for x is going to be really easy. So x plus y, which is negative 2, plus z, which is 1, equals 4. So negative 2 plus 1 is negative 1. And if I add 1 to both sides, then I get my x value. X is equal to 5. So that's using Gaussian elimination to get your solution. There's our solution right over there. And that'll be it. So if you wanted to, you could go back and plug in to the original equation. But that's the procedure that you would go through. Okay. So that's all I got for this one. I think that's a good place to end this video. Then I'll pick up with Gauss-Jordan elimination, which is just a few more steps after this to get Gauss-Jordan elimination. and that'll be that. Okay. All right. So yeah, I'll continue erasing. I'll see you at the next video. Bye bye.